The three conditions of continuity on a point. A function is said to be continuous at x is equal to c if the following three conditions are satisfied. First, the f of c must exist. Second, the limit of the function must exist. And third, the f of c is equal to the limit of the function. If at least one of these conditions is not met, our function is said to be discontinuous at that certain point. For example, we will determine if our function is continuous or not at x is equal to 1. Our function is x cubed plus x squared minus 2. Now, we will use the three conditions to check if our function is continuous at x is equal to 1. Let's start with the f of c. Since the given x is equal to 1, so the f of c is equal to the f of 1. So f of 1 is equal to x cubed plus x squared minus 2. Substitute the value of x with 1, so 1 cubed plus 1 squared minus 2. That's 1 plus 1 minus 2, or it is equal to 0. So our f of 1 or the f of c is equal to 0, so we have an okay, our condition number 1 is okay, which is the f of c exists. Next is the limit should exist. So the limit of f of x as x approaches 1. So we will use the theorem number 2 of the limit theorems. Limit of x cubed plus x squared minus 2 as x approaches 1. We will plug the value of 1 to all values of x. So that's 1 cubed plus 1 squared minus 2. That's equal to 0. So the limit of the function as x approaches 1 also exists, which is equal to 0. The third condition states that the f of c must be equal to the limit of the function. So we have solved earlier the value of f of c, which is f of 1, or it is equal to 0, and the limit of the function, which is the limit of x cubed plus x squared minus 2 as x approaches 1 is also 0. Therefore, the f of c is equal to 0, which is also equal to the limit of the function, which satisfied our third condition. Therefore, our function is continuous at x is equal to 1. Another example, determine if f of x or the function is continuous or not at x is equal to 0. Our function here is x squared minus x minus 2 all over x minus 2. So our x is equal to 0, then the f of c is f of 0, which is equal to x squared minus x minus 2 all over x minus 2, or that's 0 squared minus 0 minus 2, which is negative 2, all over 0 minus 2, that's negative 2 as well. So negative 2 divided by negative 2, that's positive 1. So our f of 0 or f of c is equal to 1. Therefore, our f of c exists. Next, we will determine the limit of the function. So the limit of f of x as x approaches 0. So same process here, limit of x squared minus x minus 2 all over x minus 2 as x approaches 0. So that's 0 squared minus 0 minus 2, that's negative 2, all over 0 minus 2, that's negative 2. So negative 2 divide negative 2, that's positive 1. So the limit of the function exists, which is equal to 1. So let's move to the third condition. So we knew the f of c is f of 0, which is equal to 1, and the limit of the function, which is limit of x squared minus x minus 2 all over x minus 2 as x approaches 0 is also equal to 1. Therefore, our f of c is equal to 1, which is also equal to the limit of the function. So we also satisfy the third condition. Therefore, our function is continuous at x is equal to 0. Okay, we have the same function which is x squared minus x minus 2 all over x minus 2 at different x is different point, which is at x is equal to 2. Now, we will determine first the f of c. So the x is equal to 2, so the f of c is f of 2, which is equal to x squared minus x minus 2 all over x minus 2. So we will direct substitute all the values of x with 2. So that's 2 squared minus 2 minus 2. So the numerator is equal to 0, and the denominator, that's 2 minus 2, is equal to 0 as well. So this is undefined. So the f of c is undefined. So it is safe to say that our function is discontinuous at x is equal to 2 because from the first condition is already undefined. We knew that the function is continuous if we have satisfied the three conditions, but in this case the first condition is failing. So the f of c must exist, but for this example the f of c is undefined. But anyway, we will just proceed for the next step and the third step to check the values of the limit of the function. Okay, so the limit of the function as x approaches 2, we have known already that that is 0 over 0, which is, this is an indeterminate form, 0 over 0. So in order to find the value of the limit, we should use rationalizing or factoring. For this example, we will factor this one. X squared minus x minus 2, the factor is x minus 2 times x plus 1. So the common factor for numerator and denominator is x minus 2, so we can reduce the x minus 2 in the numerator and denominator, leaving the x plus 1. So the limit of x plus 1 as x approaches 2, that's 2 plus 1, which is equal to 3. So our limit exists, which is equal to 3. But in the third condition, the f of c, which is undefined, is not equal to the limit of the function, which is equal to 3. Therefore, this function is discontinuous at x is equal to 2. Another example, determine if the function is continuous or not at x is equal to 4. Our function is a piecewise function, which is x plus 1 if x is lesser than 4, and quantity of x minus 4 squared plus 3 if x is greater or equal to 4. Now, let's start with the f of c. Since this is a piecewise function, we will locate the equation that we are going to solve, which is at x is equal to 4, which is at the second piece, x minus 4 quantity squared plus 3, because it is the x here is equal to 4. So the f of 4 is equal to x minus 4 quantity squared plus 3. So that's 4 minus 4 squared plus 3, or 0 plus 3, which is equal to 3. So the f of 4, or the f of c, exists, which is equal to 3. Next is the limit of the function. Since this is a piecewise function, and we have to determine the limit of the function at the left, and also the limit of the function to the right. So for the left, that's x is less than 4, which is x plus 1. And for the right, we will use the second equation because the x is greater than 4. So we will use x minus 4 squared plus 3 for the limit at the right. Okay, the limit of f of x as x approaches c negative is this one, x plus 1. As x approaches 4 minus, so that's 4 plus 1, which is equal to 5. For the right side, the limit of the function as x approaches 4 plus, that's quantity of x minus 4 squared plus 3 as x approaches 4 plus.